Okay, let's talk about REST. So REST stands for Representational State Transfer. And those three words say a lot, actually. It's about transferring the representation of the state of something somewhere else. So the representation would be maybe a piece of JSON that describes something. The state is the properties and values. You know, what's the record in the ISAM file look like right now? Is the current state. A representation of it might be a piece of JSON that represents that state. And REST is all about transferring that somewhere else to a client. Or vice versa, transferring the state of something from a client into our environment so that we can update something in our database, for example. That's essentially what it's about. It's about transferring data from one place to another. So REST, it's a design pattern that is intended to give you some rules that you can follow to provide a way of being interoperable between computer systems. So you're accessing and manipulating textual representations of some resource. In the original web world, a resource is a web page, a JPEG file, a PNG graphics file, a movie. In our world, the resources that we're transferring around are customer records and employee records and orders and inventory and stuff like that, right? It's just pieces of data. So whenever you see the term resource or resource, it's record, okay? We're transferring data around, essentially, and validating it and storing it and updating it and so on. REST has some architectural goals, and this is the whole point. The reasons you would use REST are, one of its architectural goals is that it's intended to be accessible from any environment. Okay, so if you've got a REST service, it should be pretty much possible to access that from any development environment, any language, any platform. It's built from the ground up on HTTP and string data. Pretty much every platform and every environment out there can deal with HTTP and string data. Okay, so one of the big benefits of using a RESTful approach is there are no limits on where you can talk to it from. Simplicity through use of a uniform interface. Okay, so what this is saying is that if you follow the rules and if you always do things in a certain way, then it should be possible to pretty much look at the very top level of a web service and look at the basic documentation about how it works and totally understand the whole thing and how to use it. It's almost self-descriptive. In fact, it's a shame, but strictly speaking, to be RESTful, you should be able to make a GET call to the base URL of the service, and I'll explain what that means in a moment, but the top of the site, essentially, the home page, if you like, and get back a description of all the different things it supports. And you should be able to then make a call to any one of those and have it tell you about what you can do within that resource. That's one of the things that most people don't implement, unfortunately. Most of the RESTful Web APIs that I've ever seen, certainly, produce self-documentation in terms of web pages that you can look at. And some of them go some way to making the things self-navigable. One of the common examples I mentioned earlier is when you create something, it's a good practice to return a location header that gives you the URL of the thing that was just created. That's a simple example of being self-navigable. I created it, oh, there it is, I can go get it now. But in theory, if you read the purest REST books, you should be able to make a call and have it say, these are the operations that are available to you. Oh, and pick that one and make a call to that one and have it tell you within that operation what sub-operations are available and what methods are valid and so on. I've yet to discover a website that actually does that, unfortunately. But it would be cool. But certainly, that's not to say you shouldn't have a uniform interface. And what I mean by a uniform interface is following certain rules like the way you describe things. So if I've got a base URL, which is mysite.com/API, if I'm then exposing customers and orders, then my URL should be /customer/order. It should be obvious what that is doing, okay? and following the rules like a get retrieves, a post creates, a put updates, and a delete deletes. Following those basic rules. Following basic rules like if you're exposing /customer, then if you append / and an ID, you're retrieving a specific customer. Equally, /order /ID, you're retrieving a specific order. /vendor /ID, you're retrieving a specific vendor. That's a pattern that if you follow, they all work the same way. That's the point of uniform interface. Okay, so doing things the same way. Web API, you'll see as we get into how Web API works, it really helps you do that because it kind of automates a lot of stuff for you. And another architectural goal is performance and scalability. These things are supposed to be, by design, lightweight, through things like having no state around and stuff like that. They're supposed to be blisteringly fast. And certainly compared to any other kind of web service I've ever used, that is certainly the case. Now, of course, you can destroy that performance in your code if you choose to do so. You know, if you choose to do stuff like, sure, I'll let you request 58,000 customers all in one go and it's going to return 16 megabytes of data to you, then if you choose to do that, then yeah, you're not going to be that scalable. So it's always subject to good design. So REST is a design pattern. It's a suggested set of guidelines. It's not a spec. It's not a specific product. It's just a way of doing things. SOAP is a protocol. Okay, so SOAP in the old web services way or world is a very specific set of rules. You have to do this, and you have a SOAP header and a SOAP envelope, and within the envelope you have there's a whole hierarchy of stuff you've got to do. REST is not, it's just a suggestion. But it does use standards. So heavily used are the standard that defines what is a URI. How should URIs be structured? The HTTP specifications are heavily important to REST because one of the requirements to be considered a RESTful service is that you use HTTP explicitly in the way it's supposed to be used. So you use the appropriate methods for the appropriate types of activity, you return the appropriate headers that you're expected to return, and so on. And JSON, the spec for JSON is fairly important as well. But there's no spec for REST. There are, depending on which websites you read and which books you read, 5 or 6 main guiding constraints to define a RESTful system. I've gone with talking about 5 here. I think the other one is a little bit less important, but anyway. These are the main principles. By conforming to these principles, you can be considered to be a RESTful service and therefore expect to get the benefits of that in terms of performance and scalability and being open and being accessible from anywhere and all that kind of stuff. So services violating these constraints are considered not to be RESTful. And of course, like everything, there are the purists out there that say, can't do that, you're not RESTful now. Well, you know, I personally like to apply a bit of common sense as well. And sometimes it can go a little bit too far, and sometimes bending the rules just a little bit still makes sense to me. So apply a level of common sense and do what you think works best. But try and stick to the basic principles. The first constraint is client-server constraints. RESTful services must adopt a client-server style. Well, duh. That one should be pretty obvious. More importantly, we're trying to achieve a separation of concerns here. This is why we're separating UI from business logic and data storage. But this one's pretty straightforward. If you're implementing a web service of any kind, it's because you want to be a client server. So I think that one pretty much goes without saying. But even within the implementation of a service, there are some things you can do along those lines. A web service could be just a big blob of code in a method, but there are some things you can do within the context of how you implement the service that kind of follow this principle further. One of the things we're going to talk about later on is using something called the repository pattern. And the repository pattern is within the web service, within the back end of a service, separating the concerns of business logic from data access and having a layer that accesses data that the business logic uses. So, you know, providing separation of concerns even within the back end. And that kind of goes along to this constraint as well. The second one is very important. Pretty much RESTful services are required to be stateless. So no client context should be stored on the server between requests or in the server between requests. Each request from a client must contain all of the information necessary to completely service the request. If there is any session state, if you are trying to come up with something that looks like a session, that information should be basically held in the client. So passing things backwards and forwards. Now, as I mentioned earlier, you can apply variations on the theme to that. Potentially, you could store something away in a database on the server and have some ID that lets you get back to it, and rather than sending the whole thing backwards and forwards through a cookie to the client, you send the ID, and next time you can restore it from the database. That's fine. Okay, it's not ideal from a performance standpoint. It's best avoided if you can. That sort of thing is acceptable, but certainly not holding in memory a whole blob of data like the old ASP.NET session stuff, where we'd throw megabytes of data into the session and it would, through a cookie, come back and restore that same bit of process space later. Kills scalability and pretty much kills performance as well. So aim to be stateless. If you really need to store stuff away, then save it away and return a small, unique identifier that lets you restore it next time. Cacheable constraint. Clients and intermediaries may cache responses. So responses, if you want to be strictly speaking considered RESTful, responses must either explicitly or explicitly define themselves as cacheable or not. Web API by default will add headers to the response that says this content is not cacheable. Okay? Now it's not to say that some server down the line somewhere won't ignore that and cache it anyway. And there's nothing you can do about that. So the point is, if you want something to be cacheable, you should declare it as such by declaring the various response headers that declare this content is cacheable and it's cacheable for this amount of time. And equally, when you're writing a client, you should be checking for that information. And if you are told something is cacheable for the next 6 hours, cache it for the next 6 hours, because you're going to avoid making subsequent calls to the network, and you're going to wind up with way better performance because of that. That's the whole point, right? So cacheable is one of the constraints that should be considered. Uniform interface, this one we just kind of talked about a little bit earlier on the earlier slide, so we'll breeze past this one. But fundamental to the design of any REST service is the way that the interface is defined and structured in this sort of way. I already mentioned that in Web API, there tends to be this default /API part of the URL. You don't have to have it, but it's there by default. And then within that, we start to identify what is the part of the service we're trying to access, giving some data, drilling down, but this hierarchical structure and nature, and also to the extent of naming conventions and how things are named. And there's no real standard, but the point is be consistent. So your whole service looks and works and feels the same way. Okay? Operations on resources specified by HTTP methods, so explicitly doing a get to retrieve, a post to create, a put to update, and a delete to clearly delete. And self-descriptive messages. So that, for example, is saying, through the use of the content type header, to say, I am going to tell you that I am sending you JSON data or I am sending you XML data in both directions, from the client and the server. The relationships between the URI and the methods, again, we've mentioned this a few times, so we can skip past this table, really. If the URI tends to be looking in this kind of format, it's the name of some resource, that can be considered kind of the base address for that part of the service, for the customer controller, as it happens. We'll come on to that in a few minutes' time. But if you just make a call to the base of that resource, and if you're doing a get, you're pretty much asking it to return all resources. So give me all the customers, all the orders, all the whatever. Clearly that might not be something that's desirable. Depends on what it is and how much data that could result in. If you're passing a resources and then some identifier and doing a get, you're asking it to return a specific something that's identified by that identifier. Whether it's numeric or whether it's string, doesn't really matter. If you do a post to the base address, you are typically saying, please create one. If you do a put, you specify the ID that you're updating, and you're asking it to replace one. If you do a put to the base address, you're replacing all of them. It's grayed out because it's commonly not supported. But if you wanted to support a update many, then that's how you would do it. You would do a put to the base address of the resource. And similar with delete. Delete all of them or delete just one. This is the thing that I was talking about a few minutes ago. But essentially, this is the thing that says it should be totally self-descriptive. This is the thing that says I should be able to go to the base address and get a description of all the operations. And I should be able to go to any given operation, it'll tell me what all the sub-operations are. Okay, so this is the thing that people don't tend to do. It's one of the most commonly ignored parts of the whole REST step. I don't actually know why, because it's actually a great idea. The whole hypermedia rules, what happens with a web page? All this says is, let's make our web service behave like a website. Right? When you go to a website, you have no clue how to use it. You just go to the home page and there's a bunch of links there. In the old days, it was physical hypertext links. Now it's images and buttons and all kinds of things, but they're all links. So all it's saying is you go to the home page and there's all your options. Click on one of them. HATEOAS is basically saying the same thing. Go to the base address and it'll give you a list of links that are valid. Then you go to one of those and start operating into it. And assuming the service has a consistent API, it should be obvious what your options are and how to do it and what you can do, what you can't do, and so on. But like I say, that's the one that tends to get ignored most of the time. Layered system constraint, complex way of saying clients can't tell whether they are connected to the server directly or not. This is coming back to the cacheable thing. So RESTful APIs are supposed to be cacheable, and it's supposed to be that the client should have no clue whether it's talking to the actual service or some intermediate cache. Okay, it shouldn't make a difference to it. And as long as everybody's following the caching rules along the way, then that should be fine. So you can use intermediate servers to improve things like scalability and load balancing and do caching and all that kind of stuff. And because there's no state involved, you can have a whole farm of these things out there in the Azure cloud and just go up and say, oh, I've got 5 instances right now, make it 10. Boom, now you've got 10 servers and everything still works okay because you're not relying on state in memory on that particular instance of that particular server running on that thread. You can go to any endpoint for the whole service and everything still works. Okay. Okay, why use REST instead of SOAP services? I think it should be fairly obvious at this point. They're certainly more open, you can reach more clients. There's a lot more requirements if you're trying to talk to SOAP services and a lot more things that you have to do and you have to put messages together in certain ways and so on. There is almost certainly, assuming you code appropriately, less overhead, less duplication of effort perhaps, a more standardized approach, more human readable, easily testable. And we haven't talked about content negotiation in great detail yet, but content negotiation is the thing that says, you get to say, I'd like XML or JSON or this or that or some CSV. You're not forced into using any particular dialect for representing data. You should have a choice.